In this video, we're going to talk about operations with fractions. And by operations, I mean addition, subtraction, multiplication, and division. We're going to start with multiplication, go to division, and then we'll go to addition and subtraction because they're a little bit more complicated. When we're multiplying fractions, what we're going to do is we're going to make sure that we always have fractions or improper fractions. That means if you have a mixed number, go ahead and change it to an improper fraction. It'll be a little bit easier to multiply. After we make sure we have fractions or improper fractions, we're going to cross cancel if possible, and then we're going to multiply across. Now, we're dealing with fractions and stuff like that, and we're going to be simplifying, but I'm not going to use the prime factorization method. Prime factorization method just tells you why do we do what we're going to do here. All right. This example, we have 15 over 16 times 14 over 25. All right. What I mean by, all right, we all can see that they're already fractions or improper fractions. But the cross-canceling part, if I look at 15 and 25, they have a common factor of 5. So I'm going to divide 15 and 25 by 5. 15 times 5, 15 into 5. 5 into 15 is 3, sorry. And 5 into 25 is 5. So instead of writing 15 in its prime factorization and 25 in its prime factorization, I have the knowledge that, okay, 5 goes evenly into both of those, so I'm not going to actually take the time to go through and do the prime factorization. Prime factorization is just a tool that'll help us find those common factors, especially when we're just starting out with fractions. Now I'm going to go to 14 and 16. They both have a common factor of 2. 2 goes into 14 7 times. 2 goes into 16 8 times. And so now my problem is simplified even without using prime factorization. And so I've done this part, that part. Now I'm going to multiply across. All right. And when I say multiply across, I'm just going to take the 3 and the 7, and I'm going to multiply those two together. And I'm going to take the 8 and the 5, and I'm going to multiply those two together. And so my multiplication, all right, started with two fractions being multiplied, ended up with one fraction. I get 21 over 40, and that is simplified. There are no common factors between 21 and 40. All right, so that's multiplication in a nutshell. Let's go to division. Dividing fraction is very similar to multiplication, all right? A lot of people learn these little tricks and all that stuff like that. We will discuss why we do these things, but what I'm going to do is I'm going to use the keep, change, flip, all right? I'm going to keep my first fraction. I'm going to change division to multiplication by multiplying by the reciprocal, all right? That's why I have keep, change, flip. Remember, when I flip something, I actually get the reciprocal. When I flip a fraction, I get the reciprocal. And so I'm going to use this method to help me divide 4/5 by 2/3. All right. Keep my 4/5 the same. Change is to change that division to multiplication. And flip is to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. Now we're in the case where we were multiplying. So I'm going to do what I did with multiplication before. I'm going to make sure I have fractions, which I do. I'm going to cross cancel, right? 2 and 4 have a common factor of 2. 2 goes into 4 2 times. 2 goes into itself 1 time. That's all the common factors that I have in this problem here. And so I'm just going to multiply across. I get 2 times 3, which is 6. 5 times 1, which is 5. As an improper fraction, my solution is 6/5, or I can write it as a mixed number as 1 and 1/5. By the way, I prefer this, but as you're entering your answers online, make sure you see which way they want you to answer your problem. It may be this way or it may be that way. Always check to see. All right, but that's basically division. That's division. Now what we're going to do is we're going to get to some addition and we're going to start with adding and subtracting fractions with the same denominator, right? A lot of people think about fractions by way of parts over whole, all right? When we say that they have the same denominator, we're talking about fractions with the same whole, same number whole part, right? And so what we're going to do is we're going to add or subtract the numerator. The numerator represents the parts. Then we're going to keep the same denominator. We're going to keep the same whole, and then we're going to simplify. In this example here, we have 7 over 20 plus 5 over 20, right? The denominators are the same. So what I'm going to do is I'm going to add the 7 and the 5. 7 plus 5 is 12. I'm going to keep my same denominator, which is 20. Now what I'm going to do is I'm going to simplify. Now, again, you can do the prime factorization, or I want you to get to the point where you can look at these numerators and denominators and see their greatest common factor, right? Of course, 2 goes evenly into 12 and 20 because they're both even numbers. But the largest factor between 12 and 20 is actually 4. And so what I'm going to do is I'm going to divide 12 by 4, and I'll get 3. And I'll divide 20 by 4, and I get 5. Notice I divided by the same number, 4. That means I'm just basically having an equivalent fraction, dividing by 1, all right? And so when we finish, our solution would be 3/5. All right. Now, it's very easy to add or subtract fractions with the same denominator. It's a little bit more difficult when we have different denominators because we have 2 different wholes. So they're not equivalent or similar. And so what we're going to have to do is we're going to have to find a lowest common denominator before we actually add these fractions. All right. Let's talk about least common denominator, which comes from least common multiple. All right. To find the least common multiple, if you can't just look at it, all right, to find the least common multiple, you can follow these steps here. First step is to find the prime factorization of the number. Then you want to find the common factors. And then you multiply your common factors by your remaining factors so that you can actually get the least common multiple. All right, so this is different from finding like the greatest common factor. This is now least common multiple. And when we think of a multiple of a number, we just think of like counting by that number. For instance, the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, so on and so forth. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, so on and so forth. All right? And if you get real good at this, you won't have to go through this prime factorization process. But I'm going to do it with this example here. I want to find the least common multiple between 12 and 20. So I'm going to go through the prime factorization of 12. Okay, so 12 can be written as 2 times 2 times 3. And I'm going to do the same thing for 20. 20 is 2 times 2 times 5, right? And remember, we get our prime factorization from the bottom of our tree. All right? Well, the least common multiple between 12 and 20, all right, I'm going to abbreviate that with LCM, is going to include the common factors, right? So I have 2 in common. I'm only going to write that 2 one time. Here I have a 2 in common. So I'm going to write that 2 again. I don't want to write 2 4 times. Take the common factors. And then I've got to multiply it by the other factors. All right. And the reason that I have to multiply it by the other factors is so that I can get a multiple of both 12 and 20. Right. If I don't include this 3, then I'm not going to get a multiple of 12. If I don't include that 5, then I'm not going to get a multiple of 20. All right. So I have to include all of that. When we multiply this, that's going to be a 4 times 3, which is 12, times 5, which is 60. So the least common multiple of 12 and 20 is 60. So that means if I count by 12s and I count by 20, the first number that shows up on both lists will be 60. Okay? Now that we know how to find the least common multiple, those numbers that are in our denominator, that's what we're going to do to help us get a common denominator. These are some steps to adding and subtracting fractions with different denominators. First, we're going to find the least common multiple, that same prime factorization process, unless you can look at it and tell. Then we're going to rewrite each fraction with the denominator being that least common multiple. Then we're going to add or subtract our numerators depending on if we have an addition problem or a subtraction problem. We're going to keep the same denominator, and then we're going to simplify. So these last 3 steps here are basically the steps from adding when we have the same denominator. So we got to just go through these first 2 steps being new. Let's look at this example. And this is a fairly simple example. A lot of you probably can look at it and tell what the least common multiple of 3 and 4 is. But for those of you who might need a little guidance, let's look at it together. All right, for 3, well, 3 is a prime number, so 3 in its prime factorization is just going to be 3. All right, let's look at 4. Well, 4 can be written as 2 times 2. And so the prime factorization of 4 is 2 times 2. To find the least common denominator or multiple, whatever you want to call it, we take the things that they have in common, which is nothing. Okay, they have nothing in common. And I have a 3, I have a 2, and I have a 2, which is going to give us 12. So this goes to show, well, if I have a least common or denominators that don't have any common factors, all right, any common factors whatsoever, then if I multiply them, I'll get my least common denominator. All right, you can actually multiply any denominators to get a common denominator, but your numbers might be huge. And so we always want to go through this process to find the least common multiple to keep our numbers a little smaller. All right, so this least common multiple here is going to actually be what we call our least common denominator. All right, and some people abbreviate that with LCD. All right. And so what I'm going to do is I'm going to rewrite 2/3 plus 3/4 as equivalent fractions with 12 in the denominator. All right. For me to do that, I've got to do some clever multiplication. All right. For instance, for me to get this 3 to become a 12, I have to multiply it by 4. All right. And I can't just multiply the denominator by 4. I have to multiply the numerator by 4 to keep me having an equivalent fraction, right? Because 4 divided by 4 is the same thing as 1. They would cancel out. So that's still the same thing as 2/3. All right. Well, 2 times 4 is 8. So I'm going to write my 8 as this part of my fraction. Okay. Now we got to do the same thing for 3/4. Well, going from 4 to 12, I multiply by 3. So if I do it to the bottom, I have to do it to the top. Remember, that's the same thing as multiplying by 1. 3 divided by 3 cancels to 1. And so 3 times 3 in that numerator there is 9. So 2/3 plus 3/4 has now become the fractions, or the addition of 8/12 plus 9/12. And now that we have the same denominator, we're at this point here. Add or subtract the numerators. We have an addition. So I'm going to add 8 and 9. That'll give me 17. I'm going to keep my same denominator, which is 12. And I'm going to simplify. Well, 17 and 12 have no common factors. So this is actually completely simplified. However, if you want to write your solution as a mixed number, that'll be 1. 12 goes into 17 one time with the remainder of 5. So that'll be 1 and 5/12. All right, that's adding and subtracting fractions with different denominators. And this concludes our studies of the operations with our fractions.